Imagine an online store where every time a customer places an order and you need to process the payment, update inventory, and send confirmation email. So, doing all of this immediately, especially during peak traffic times, could slow down the customer experience. And in this case, we have a large number of application events and we can't handle all of them at once, right? So, how can we process orders? Of course, we could scale up our servers to handle these large amount of application events, but if we don't have to handle all them at once, it's better to queue these events and handle them later. So basic architecture of message queues. A message queue is a kind of durable component stored in memory that supports asynchronous communication, and it serves as a buffer and distributed asynchronous request. And the basic architecture of a message queue is simple: input service, call procedures or publishers create and publish message to a message queues. So other services called consumers or subscribers that are connected to the queue and perform actions defined by the message. In a real world scenario, let's say there can be many apps writing to queues and many servers reading from the queues. So let's get back to our example. So in our case, instead of handling each task immediately, we can add it to the back to the queue and form this queue, and they are sent to our servers. So let's say first is kind of order placed. The order details are we put in a message, and message is sent. The message is added to the queue, and there can be worker processes that will separate process worker, pull message from the front of the queue and handle the task here. Also our server acknowledges that it received and processed one message. In this case it would be the consumer, and the queue removes it so that it is not sent for the second time. So what are the benefits of using message queues? The main advantage is that we decouple these events, and this message queues will allow us to process these events asynchronously. We can queue them until we can process them. So with the message queue, the producer can post a message to the queue here, and when the consumer is unavailable to process it, so also the consumer can read message from the queues even when the producer is unavailable, so there is no issues on that. And another great benefit is that they are kind of durable. If the queue crashes, the data will be not lost, as it is not stored in RAM but it is stores in disk. So they are durable as well. So let's say if a worker crashes while processing a message, no problem. The message is still in the queue and it will be picked up by the another worker. In this case, it would be kind of another consumer. So these are reliable. So message queues only also provide scalability. If you receive a flood of orders, the queue will just get longer, this message queues, and you can add more workers to handle the extra load which affecting the site or application. So there are different type of queues. Let's discuss those. So there are multiple types of message queues. The most common ones are first in first out. Just like a regular line, messages are processed in the order they arrive. This is important for things like payment processing. And there is another type of priority queues. Some message might be more important than others. You can prioritize these so that get processed sooner. There are also some type of push and pull. Some queues wait for workers to ask for message, that are called pull based queues, while others are actively sending to worker, push based queues. These type of push based. So there are few examples of popular examples of message queues. So these are The first one is RabbitMQ, a versatile queue that is good for many use cases. There is middle in the middle Kafka, built for high throughput and real-time data streaming, great for things like logging and event-driven architectures. And the third one is Amazon SQS, a simple queue service, a fully managed cloud-based queue serve offered by AWS. It is scalable and reliable with features like delay queues and dead letter queues. So yeah, these were the kind of examples for popular message queues.